a STL is coming and the complete syllabus is coming, or the next part is coming, something like that.
It'll basically just be the next part, but like at the sense like it's also gonna be a bit of the start. Like you're gonna need like how to do the classes, how to do
Got it, got it.
all
Yeah,
that.
like
So
you
like
need
yeah,
the
yes,
basics as well.
exactly.
Yeah, makes sense. Yeah. You're able to see my screen, right?
Yes.
Ah, okay, great. So let us continue with the
Mhm.
STL part only. Hmm, hmm. So basically, we are discussing, I think, overview. I already gave you like why STL is important and all.
Mhm.
And yeah, like what are the things included in this map and all, how to include, how to write in the code, how to write bits std c++.h to include the complete C++ library. And
Yep.
then there are something predefined data structures inbuilt in there. We need not to define again and again, like stack and queue. They're already defined classes in the STL library. We just need to write import it. And yeah, time spent, it obviously it's they already wrote the efficient code. So whatever we wrote, if I write also right, it will be less efficient what they have written because they are developers more experienced. So they handle various edge cases there itself. We just need to import them. And as a performance optimization, flexibility it gives and maintainability. It's very like it's easy to look also, right? It's intuitive. Like I write the sort directly, it's sorting my array. Sort is an English word, right? You're
Yep.
sorting, you should sort array. So they made the function in such a way so that you can easily get it also. So yeah, like
No.
we talked about something about containers. So containers like whatever data structure we have help to store our data, like vectors and all, like maps is there. So that's all it's there. And then we talked about iterators. Iterators like are similar to pointers only. What a pointer do, an iterator do, but there's slight difference. Like if I want to iterate in a map, so I will use a iterator. Like if the data type of that thing, what I'm trying to iterate is iterator. And if I'm trying iterating in a normal loops, so basically that's using a pointer. Okay.
Yep.
And then algorithms we talked about, the sort algorithm is there. There's something known as max element also. So we can easily use the max element. And then, yeah, there's something like this. And then we talked about vectors. So basically, vectors we already know. We have
Yep.
been talking about vectors all I know. It's a dynamic array. Like, why it's a dynamic array? We can add elements. See, array is fixed side,
Yes.
right? Array is fixed side. But in vector, you can add elements again and again. So what are the key functions? We talked about the pushback function to add element at the back, and then there is a size function you already know. And this begin and end are the actually iterators which provides you the first and the last element. In vector, it's very easy. Like vector, you can
Okay.
easily go with v of zero, right? V of zero,
Yes.
or there is something
We
known
can
as
do.
v dot back
Yep.
to get the last element. Or if you know the size, you can know v of n minus one. But this is a case of vector. But in a map, let's say if I talk about maps, the problem is you don't know what is starting, what is ending, because there is no indexing
Yeah.
in. So that's why here you need that begin and end to get the first and the last element. That's why.
Yep. Makes
So
sense.
this is how it works. Then we talked about maps. So how to declare a map is like this is we declare a map. There are two data types. There's a key value pair. There's a key here and there's a value here, and then write the MP and all, something like that. And then this is how we define it. Generally, key is defined in such a way it should be unique because for a particular key, we should have a unique value only. So we
Mm-hmm.
have to choose the data type of key in such a way so that it will be unique. And then that most important part is this thing keys are sorted in a like keys are stored in a sorted fashion. Like if you store integers, so it will whenever you are iterating, like if I told you, give me the first element will be the key with the smallest value. That's how it
Okay.
works.
Yep.
Like and if you tell me and it will be the largest value available in the map. And this is how it works. And then lookup is based on key. Like yeah, I already told you they are sorted in a keys fashion. key operations we can do, like insert we can do, there is add and find. Let's try to understand these functions in the code itself. Like I told you something known as, if we don't use this thing, insert we can use this also. Like this is a pair, right? Like suppose you have a vector
Yep.
and you have a pair of something like it. You can treat it somewhat like a map only, because like it have a two things, right? And
Yes.
here, here you use insert to insert this key value pair. You can insert it into this way also, or you can do like this. Like suppose you want to add a 1 comma 3. Let's say our map is like int comma int only. So we can do like this. MP of 1 equals to 3. Like this. Like key
No.
is equals to 3. So generally we use this because it's more intuitive and it's like more okay, easy to understand. F1, we want the value 3. Like this. And yeah, like this is how I told you, like string. If you have a string command pair, you can do like this. Basically, here index become key only. Like in the vector part, what we have used to do, we used to do v0, v1, v2. The indexing is based on like 0, 1, 2, 3 till n minus 1, right? Here we can
Yep.
change that index. We can make it string, we can make it int, we can make it vector also. Like we can do this also. MP of, we can, for every int, we can make a vector also. So basically, you have to understand how it's working. Like now, if I ask you the data type of, let's say, MP of 1,
Mm-hmm.
what is the data? What do you think? Like, what is the data type of MP of 1? If I say,
Mm, it would be an integer.
see, I have here for particular, for every key, I am
Yeah.
associating a vector. So like, there's a key for each key. There is a vector associated with that. Means MP
Yes.
of 1 if I am doing, means this is a vector actually. It's a complete vector. I will show you the
No.
code.
Okay. Okay.
Let's try to understand this. Like, what's the difference? Because this is very important to how to understand differentiate between data types and all. Because in maps, basically, because there's various data types, right? So
Yep.
it's very important to understand it. Try to see. Starting. So basically, we are talking about, let's include the map library. Let's try to
Mm-hmm.
include. mm, mm. So basically, let's say I define a map of firstly int comma int. This is MP1, and there is another map I define of int comma vector of int.
Okay.
MP2. Let's try to understand how it's working. So basically, let's say if I do, okay, I have not included. Uh, Include vector. So basically, this is how we include the vector part. Now, let's say I do MP of 1 is equals to 3. Okay. So basically, for 1, we assign the value 3. But for, let's say, we do the same thing for second thing. Would it work? MP of 2 is equals to, let's say, 7 or what? See, this is giving me an error. Why? Because, see, I am associating key with a vector, but here I am giving an integer value. I need to
Okay.
provide a vector to it. So either I do like this. What? See, now you treat MP of 2 as a vector only. It's a
Yeah.
variable.
Then I'll. Yeah.
Now you can use the pushback functions. Got it? Like this.
Yep.
So this is how it's working. Like MP of 2, this thing is complete a variable name, becomes a variable name.
Yeah. So treat it like
Now
a whatever the
yeah,
variable you put.
yeah, exactly. So this is, I want to tell you. This is how it works. And then let's try to understand these. I already told you sorting thing. Find thing. Let's try to understand. Let's suppose uh, we take a, I'm taking an integer example only. It will be easier to understand. MP. Let's say I am inserting. This is inserting only. MP of 2. Either you do this way or you like do this way.
Mhm.
Like when you click dot, you will get all the functions. Whatever
Yes.
it's available. Begin, I already told you because it start with starting, and clear means clearing all the keys. Whatever is present in the map, it will be entirely clear. And this is not important. Empty is not important. Empty, yeah, like there is no key or not. Like you can check with the size also. There are two things to check whether our map is empty or not. Either you check the size, like either you check the size equals to zero, or if you don't want to check this, you can directly use empty function. Either like if empty dot empty.
Okay,
If
okay.
if it returns true, if you should do like this. So basically, if it returns true, that means it is empty. That's how it. If you can put in the if condition and check, okay, this is true, that means our map is empty or not.
Okay,
Okay,
okay.
got it. So let's try to insert some values in the map. 3 MP of 5 is equals to 7. So basically, what we have in our map, let's try to understand. In our map, we have like stored like this. 1 comma 2 we have stored, 2 comma 3 comma we have stored, and 5 comma 7 comma. You get it? Like these three pairs we have
Yeah.
stored till now. Okay, that's great. Let's try to understand whether key 2 is present or not in our map. How should we go about it? There are two things. Either go, if you want to search a key, what you will do, if I give you the same problem in the vector, let's suppose whether an element is present or not in a vector, what would you do? Like, how would you do that?
Sorry, what was your question?
My question was like, suppose I have a vector
Yeah.
and I want to know whether an element is present or not in a vector. So how would you do it? Like, whether the element
Uh,
is present?
so I
Yeah.
would go. I'll use a for loop. I'll basically just go through it one by one to
Okay.
see if the
Yeah.
number is in it or not.
Yeah, means like you will check whatever I number
Yes.
provide you, will check is equal or not. If it's equal, I
Yeah.
will return a true or yes, I will return. Okay, that's great. So in a map, you can iterate. Yeah, obviously, I have told you like there is a method iterator. We can use directly auto. We don't need to worry about everything. Just use auto, and we can
Yep.
iterate in a map. Now there are two things in the map. There is first thing and there is second thing. Now you need to check what you want to find. You want to match the key or you want to match the value. So for getting the value, you will use I dot second. I dot
Okay. Okay.
okay. If you want to uh, search for values, but if you want to search for keys, you can search for first also. This is how you can do that. But there is a very good way of doing it. If you want to do it for keys, like there is a inbuilt function made for that. Let's try to understand. There is no function known as find. So there is something known as MP dot. It only works on keys. It doesn't work on values. It should work on only keys. The reason also I will tell you later. Yeah. Find. Let's say you want to search a particular key. Let's say I want to search is 4 present or not. Okay.
Okay.
MP dot find 4. If it is not equals to MP dot end, let's try to decode what this statement is specifying. Let's try to understand. MP dot find. MP is my map's name.
Yep.
Dot find is a function. 4 is a key value, key which I want to search. Key I want to search is not equals to MP dot n. That means my like this will give me some value. And if it is equals to MP, see, dot end is means like it's not exactly pointing to the end of the map. It is pointing the next just next element to the end. Means like suppose I have 1 comma 2 and 2 comma 3 present in my map. Okay,
Yep.
so the my pointer is pointing just here, the end. This is end. Means end is not pointing here, not the last element.
Okay. Okay.
Just the next next memory location after that. So if I
Okay.
reach end, that means I nothing is left. I have iterated in my map, nothing I found. So this is like this. So here, if I my find function give me the mp dot end, that means the my key is not present. But If it is not equal, that means it is present. Try to understand.
Yep.
It is not equals to map dot end means it is present in my map. If it is returns true, this statement is it because it's a I am checking equal to or not equal to. So it is a boolean statement. It will either give me true or false.
Okay.
If it
Okay.
is if it is give me true, that means yes, my element is present. Let's try to see in the code itself how it works. So this is very important. Like this we will do like in every code this mp.find function. You need to understand how it works. So yeah. Okay. So is this as well? Let's try to find this. If mp dot find, let's try to search, but something is present. Let's say two only. Two not equals to mp dot n.
Okay.
So let's try to see. Okay. So now if I will say I found the element, I found the element. Else key key not present. Let's try to see how it works. Yeah. Hmm. So basically, yeah. So it say I found the element because two we have in our map. See, not these two, this not this one. It is searching for these keys. Okay, I am
Okay.
searching not for the value because keys are unique, right? That's why.
Yeah.
Because I can have this also. This is fine. Two keys have same values, but one key can't have two values, right?
Yes.
So yeah, let's try to search for let's say something not present. Let's say 9. So key not present. So this is how it works. So this is find function we have discussed, and size function we already know like in same thing as vector. And what else? Find we have done sorted. I already told you in the maps. Okay. Now let's try to understand. There's something known as unordered loop. Okay.
Okay.
Now the previous one was ordered. Ordered. What's the difference between ordered and ordered? Ordered means like there is keys are sorted in increasing fashion. Keys are sorted in increasing order.
Okay.
Matlab, it doesn't matter how I push my elements, how I inserted my elements. Again, what? Let's try to take the example of vector. I suppose I push one, then I push two, I push three,
Yep.
I push four. This would be the vector will be same. There will be no order change. It will preserve the order. But if I talk about map, let's say I pushed 1 comma 2, then I pushed let's say 2 comma 3, let's say I pushed then 7 comma 9, and I pushed 4 comma 3. Okay, so it will
Yep.
sort. Okay, after first operation it will be like this, then it will be 2 comma 3, then after 7 comma 9, okay, 4 comma 3 is 4 is lesser, 4 comma 3 will come first, and then 7 comma 9. So this is how it will store in this fashion. Map. Unordered map is something different. This will store in random fashion.
Yep.
It does not preserve the order also. It's not like vector also. Ki whatever way I am pushing, it will preserve the order. No, it will in random order. Now you will ask me, ki what is the use of this unordered map? If you have map, at least it gave me sorted fashion, and it is giving me some advantage also. Ki at least I know the order. Here it is doing the same thing as map, and it's not giving me any advantage. You will think like this, right?
Yeah.
Now, I will tell you the most important difference between unordered map and see, when there is what why a data structure is how I check a data structure is good or not. I told you I think in the first class, one of the first class,
Yeah.
like we check the time complexity because how fast is the insertion, how fast is the deletion, how fast is the searching time. That is the thing we want looking for, right? That is the
Yes.
parameter we should check about time complexity, space complexity, and obviously the correctness.
Yep.
Correctness, so everybody is there. Obviously, they implemented the data structure, so they would be correct. There's no doubt about it. If they're not correct, then we should not study them.
Yes.
But yeah, correctness, I am assuming it's to be correct. Space complexity, everyone is storing eventually pairs only. So space also, they're taking same. Nothing changed here. Major role player here is time complexity. Now, how to
Okay.
deal with it? This is very important. Okay, okay. Let's try to understand. There is some let's try to vector. There is map, and there is another.
Okay.
This distinction, no, this is very important to understand how I am doing it. Uh, what are the time complexity of every operation? Let's try to understand insert time complexity. What do you think? In pushback, what is the time complexity of inserting an element in a vector? At the end, obviously.
Hmm.
Yeah,
Uh,
make a guess.
yeah. Sorry, wait. What were you
Yeah, make
asking?
a guess. I am asking, like, let's suppose my vector is like this. Now I
Yes.
want to insert 3 in my vector. What is the time complexity of inserting another element in my vector?
Oh, it'll be pushback, no?
Yeah, pushback. But what is the time complexity? Like constant, linear, quadratic, like that.
Oh, okay, okay. So the time complexity for this would be uh
Mhm.
linear, no?
See, I'm not inserting at any random location. Yeah, if your answer would have been correct, if I say at any random, like any position, if you want to insert, yeah, it is linear. But suppose I just want to add at the end, one, two, three,
Okay.
four. That would be constant, right? Only constant amount of time it takes. If I want to insert at the end. But if you want to insert, let's suppose here, any specified location, that would be linear. You
Yeah.
have to iterate and then. So, okay, but in general, I am talking about in the end only. I'm not talking about any specified location. So, I would be considering of constant, like of one. Okay,
Okay, okay. Got it.
and now map. Map, you obviously don't know. I will tell you. See, map, they are sorting it. So, every time I insert, they need to resort it again. And this,
Yep.
they are doing like this is a mathematical thing. You can remember this. This takes long and you know something known as binary search, by the way.
Yes.
You have a bit of idea, right? I will talk about it
Yeah.
if you don't know. So yeah. So let's assume like binary search also take a certain time of log n, right? So this is somewhat similar to that because we are sorting it also and it's checking. So yeah, it takes log n time to insert.
Okay.
And here it is also map, but it takes off one time only. I will tell you what's the difference. Like we will go deep everything. This table is very important. This O1 is I will mark a star. Why I will tell you why I mark the star. Everything. Okay. Let's try to understand deletion.
Okay.
If I want to delete from the back only. What do you think? Like if I want to do 1, 2 to 1, just one. So yeah, what do you think? What's the time taken to delete an element from the back in a vector?
Mm, would it be give me one minute. I'm just looking.
Yeah, it's fine. Totally
Okay.
fine. But if you will think, no, you will obviously remember that, oh, you told me this. Okay, okay, yes, like this. Yeah. Try to think. No
Yeah,
problem.
yeah, that's what I'm thinking.
Mhm.
Deletion.
There's something non function known as pop back.
Yeah.
Yeah.
So I think it would be basically just be like the s- space for the one. So it'd be like zero bracket C for like
Mhm.
capacity, right? And then times S, which would be the size.
Okay. Okay, like that. Yeah, yeah. Like on an average, I can say it's of one only. Like it will take constant time only. Like size thing, I think like in general we say
Or
it's
yeah,
of one
zero
only.
equals one. Okay. Zero equals one.
Uh, yeah, sort of. It's like works like that only. Like I think whatever you're talking about, there's something known as heap. That
Oh,
thing,
okay.
that the size, it depends on size. The deletion and insertion depend on the size. I will tell you this also.
Okay.
So yeah. And if I talk about in map, it will take same log and time. Log and time to delete also. Here also I mark a star and it will take over one time. And now searching. Let's try to search an element. So like you told me, if you will have to iterate right to search an element.
Yep.
So here it's O of n, because you need to, obviously searching is not that checking the last element, right? Searching means you need to know and any element in anywhere, right? So that's why I take O of n time. But in map, surprisingly, it will take only log n. Here it's the added advantage in the map, but here it's another advantage. It's O of one only. You see.
Okay.
Now why I marked star mark here? Now you will tell me, uh, then you why you're using map though? Then you should use another map only. That everything is O of one here. Why you are using map? Why you using? Obviously, you know that, right? Log n is greater than
Yeah.
constant. Okay. So, why you are using unordered map then? See, these are average time complexities. Average time. Like
Okay.
in general, it's fine. But in some certain cases, if I set the test cases like that, certain cases, the first time, like it happens very rare. Like this is something I want to tell you because this is very important to understand. Like this is the core crux of this the comparisons, because you should know why you are using a data structure over other. This is I'm not sure is it covered in your course or not, but this is important for like interviews and all. It's very important. You need to understand these concepts. It will be used, okay? So don't think like, oh, it's like something very difficult to understand. Not able to understand. Ask me again. I will repeat it. Okay.
Yep.
So yeah. So worst time is can go up to 4 5. This is in map case. The worst time of everything can go up to often. But in general, average and best case is of one only. So that's why
Yep.
there is a there's to be on safer side we use map, because we know exactly it is will take log n only. We are not ambiguous that it will take whether of one or it will take of n. We don't know. Here we are sure. Here we are sure. Okay. Suppose I want to do just insertion and deletion only. So I will use that obviously. But if I want to search also, I will use map, because overall it is better, because O of n is bad and O of log n is good.
No. Okay.
Okay. So yeah, because n and log n, obviously log n goes slower and goes like this. If you just remember, this is n and this is log n. It's like this. This is log n and this is n. So this log n grows slower as n becomes large and large. So yeah. So this is the comparison I want to tell you. Yeah, mostly then unordered map. Hash base is like, yeah, like same thing you can do whatever do in your map, you can do here as well. Faster access time than map. Like this we have discussed. But there's a star mind over here. Yeah, like on an average. On an average. Worst case I already told you. Yeah. So yeah, let's try to understand then. Yeah. Now okay, sets, let's try to understand the set. Okay. There is something known as set. Set. Uh, you can say, I don't understand what is a set. Set is something as a vector only, but it's so the same thing sorted in a sorted order, like a uh, map only. But here there's no key value pair. Here set stored only single value only. Let's suppose set is like, you can imagine like this 3, 4, 7, 9. Okay, this is my set. It will store in the increasing fashion, same as map. Store in increase sorted order. I should say uh, order. Okay. And now the most important part of the set is this thing. No
Okay.
duplicates allowed. Means if I insert 3 again, so it won't be inserted because it already have 3, and it will check whether 3 is present. Oh, 3 is present. Oh, I won't insert it. So yeah, it won't give you an error. You will insert it, but it won't add it up. Like I will show you how what I'm saying. Let's try to declare a set. Okay, this, let's say I declare a set, then I declare, this is how you declare a set, because it's not the key value pair, it's single, like similar to vector. Just that it's what it does, it stores the data in a sorted order. Obviously, there is no concept of indexing. You have to go in the with the help of iterator, same as map. So let's say S, this is my set. Now let's try to insert some element. This method to, here is not pushback, here is insert, same as map. Insert, and let's say 552
Okay.
add. Similarly, let's try to insert some elements. Let's say insert 2, I insert, and 1 I insert. Let's try to check the size first. Just dot size. Let me just comment this thing. Okay, let's try to see what's the size. Okay, size comes out to be 3 because 3 unique elements I pushed. Now let's try to check the size now.
Mm,
It's still 3. Okay, why?
yeah.
Because I pushed 5 one more time, but it's already contains 5, so it won't insert. But had it been a vector, it will push it, right? It doesn't care
Yeah.
about duplicates. The size would become 4. So here is the difference between a vector and a map and a set. Yeah, this is how, like, there's very various data structure. What you want to implement, what you want in your project or what. So that's how you should choose. What are the trade-offs you want to do? Yeah. And yeah, similar functions like insert. If you want to insert an element, if you want to find the element, same stuff. Like s dot find, similar as map, s dot find. Suppose you want to find whether 7 is present or not. 7 not equals to s dot end. If it is gives you true, that means 7 is present.
Yeah.
Yeah, true. Exactly. And there is something known as erase function.
Yeah.
Now see, there's only one element. There's only one occurrence of everything. So if you erase, so obviously there is only one occurrence, so though it will be erase this thing. So yeah, you can do like this. So show you as well. Let's try to erase something. We have inserted it. We have inserted the size. Now s dot erase. Let's say 9. And now important is 9 is not even present. So would it give you error? No, it won't give you an error. It will first search itself. We don't need to do that. We don't need to write the code. Oh, firstly you search and then you check, okay, is it present or not? If it is present, then delete it. No worries. If it is not present, no problem. Basically, no problem with that. But suppose let's check the size. Yes. Then we will erase one, two. Okay, let's try to erase two. So yeah, it will find it and it will delete it. So it will delete it. But if it doesn't find, it won't delete anything. Okay. So It doesn't even throw an error. It just checks, oh, this element, whatever you gave me, it will check it is present or not. If it is present, then it will tell you.
No,
So
okay.
this is map store unique. This is the most important part. Store unique listed elements, no duplicates allowed, and yeah. So this is how. And similarly, this unordered set, the similar idea as unordered map. Here also, the time complexities are login, similar as map, login and all for everything, like for insertion, deletion, searching. Here, similarly, on an average is of one, but again a star mark. And then it's also stored the unique element. This preserve the same property, but in an unordered fashion. Means it does not store in the sorted fashion. Let's try to
Yeah,
see this also. Let's try to see this. So I push this element. Let's try to iterate over the map and check how it is storing. For photo, I in any STL function asset and all use auto best. Now you know that. See, you're iterating and you're in a map, and this I is an integer. It's not a pair, it's an integer. So basically, yeah, you just need to do I and of L. Here you don't need to do first or second, right? Because there's no pair. There's only a single elements we are storing in the map, in the set. Okay? Yeah. It
yeah.
will just give me 1 to 5. Firstly 1, then 2, and then 5. Because it will sort. I pushed in 5 to 1 fashion, but it will give me eventually in the sorted fashion. Let's try to see unordered map as well. Let's try to include that unordered set. Include unordered set. Okay. Unordered set. If I make it unordered set, ordered set. Okay, so basically I inserted it. Let's try to see. Okay, this is a random. Okay, it does. Let me just insert one more element. Yeah, it's very random. So maybe there are three elements only. That's why it's sorted. Yeah, see. Okay, this is a random order. You don't know like what will be there. Yeah. This is the difference between another map and set and all. And yeah, this is we have done. This we have done. Multi-sets. Now there comes a picture of a multi-set. Now, what's the difference between a set and a multi-set? See, multi-sets can allow duplicates element as well. It preserves the property. It keeps the element sorted. No problem here. It allows duplicates. That's the difference between a set and multi-set. Allow duplicates.
Okay.
And elements are still sorted. And there's some other operations also. Now there is something comes another function count. Why? It helps you to count the frequency of an element. Let's suppose I have a vector, let's say 2, 3, 3, 4, and 7. This will store, it won't discard two occurrences of 3. It will preserve that. But here, the count method will help, right? In the previous thing, we don't need count method because we know either the element is present or it's present once. It's not cannot be present more than once, right? So what is the use of count then there? So that's why here count is important because here it won't discard the duplicates, but it will eventually sort them. But 2, 3, 3, 4, 7 like this. So this will help me count the frequency of the element. Okay, this is how it works. Elements are still sorted. It's like you can say combination of vector plus set property. So it allow duplicates as well. It but it do sorting as well. So see, these are like developers are there. You give the properties, they make the data structure according to you. So yeah, sometimes these are also important. Sometimes you need duplicates. Sometimes you don't need duplicates. If you don't need duplicates, use sets. If you want duplicates, use multi-sets. That's all. but because you want the sorting property. Okay. So based on the requirement, what you want, this is you need to do. Okay, let's try to see the multi-set as well. Let's say multi-set, multi-set, and all. Yeah. So we've included the multi-set. Let me just bring this down. Now there is a more very interesting part of multi-set. It's not right. Oh, okay. Very sure. Should be multi-set. Okay, what happens? Just a second. So multi-set is not coming. No derivable. You find multi-set. Should be there. Just a second.
Okay.
Oh, oh, just a second. Okay, I will use another problem. Sometimes it gives error. Sometimes. Mm, mm, mm. Basically, yeah, we have included the complete library because this bits function, no, sometimes it gives error because of the include path. So you have to include it very like add some environment variables in your laptop. So you have to do that. Yeah, this actually it works in my one folder. I don't know why. Like this, if I include in any other folder, right, it will tell
Mm-hmm.
me error. If I but in a
Oh, okay.
particular folder, it won't show me error. So I use sometimes this folder. So yeah, to use this.
Okay.
Yeah, so I let me use the multi-set. Multi-set in this. Okay, so this is how multi-set is there. Same, you can insert in the same fashion insert. Once you understand one data structure, right? Like every data structure is very
Yep.
easy to understand. All functions are same. Insert, erase, find, empty, size, all functions are similar. That's why there's a very organized way. Just you need to focus on understanding one thing. And then you understand it. Let's say answer at 2 as well, and I inserted 5. Let's check out the size and let's check the printing also. Just out size. So yeah, that should give me 4 because it will allow duplicates. It's still a
Yep.
set, but it's allowing. Let's try to print it. It will give me sorted fashion as well. I
Yeah.
guess this is how it is important. Yeah, yeah. So this is like 2235. Fine. This is the
Yep.
size, and this is yeah. This is how multi-sites works. And I think, yeah, unordered, we don't use it much. Maps, I already told you, unordered, we told you. Conclusion, yeah, let's try to see one problem as well, and then we will write it up. Basically, what is the essence? Like, there are many things more, like there are tons of things in STL, but we have to focus on some important things. We will focus on that. Mostly, it's like that only. Once you understand these concepts, right, then you will able to understand any other thing. Let's suppose I gave you another, there's something known as a max element. Now you will
Yep.
understand, okay, this is something, okay, this is will give you, let's try to see how it works. Let's say in a vector, you want to find the max element. There are two ways. Either how to do that. Let's say I give you a problem, find the maximum element in my vector. In
Yep.
we, let's try to push some elements. Push back 5, let's try to push, let's say 8, let's say 1, let's say 10. Okay, so I pushed 4 elements. I want to get the max element. This is a very cool way of doing it. See, let's try to do it auto. Whenever you want, you don't know what's the data type is coming, use auto. It's very easy. Okay, let's try to see this as a max element underscore element. This is a function now. What it takes, it will tell you, okay, it will take a forward iterator and then a last iterator. Like from where you want to start and from where you want to end. We want to start from the beginning, okay? So Our
Yeah.
question will be v dot begin, and what is where we want to stop v dot end. Yeah. So what it will do is it will give me a pointer to my max element, which is 10. Okay. Now,
Yep.
if you want to get the value from this, IP is a pointer type because this is by default give a pointer. If you want to get the value, you just need to view dereferences pointer. Star. That's it. Okay.
Yep.
This is well. Let's try to see if you want to take the max element. So yeah, it gives you 10. Okay.
Yep.
Now, same thing. If you can do min element, there's something they're inbuilt. I'm not defining this. I can define this function as well, but they're already inbuilt. They already specify these things. Yeah, I will get the minimum. I got the minimum one, and then 10. We can sort it. We can. This is like these are the functions you need to see in the everyday life. Then yeah, the key takeaways what we have studied today and like been discussing yesterday as well. Like STL provides an efficient solution for the common programming tasks, containers, iterators, and algorithm, streamlining coding and mastering. STL is crucial for high performance application because we want optimized code, right? We don't want
Yes.
manual. Suppose I wrote maybe a function, maybe it's good, but suppose it's taking too much time and it's not optimized for everything. They already optimized it, we just using it. So yeah, it's very useful. And mostly this is good. Let's try to solve one problem and then we'll find it out. So okay. So okay, let's try to understand we understood map part, right? Let's try to okay, duplicate to you will understand. Okay. What should I just give? Okay, okay, fine. Okay, I give you a problem. So I will give you a vector.
Okay.
Okay. Let's say 1, 2, 3, 10, 5, 5. Okay. I want to tell the frequency of each element.
Okay.
Frequency of each element. From what data structure you will use and how will you do it? Tell me.
Okay. Give me 1 minute. Let me think.
Yeah.
So in this case, the frequency would, for most of them, so be one would be one, two would be
Mm-hmm.
two, three
Mm-hmm.
would be three, 10 would be one, and then five would be two.
Okay. That's fine. Okay. Means like how will you do it? Like I want write a code for any general vector.
Oh,
I'm
right up
giving this.
after do it writing a code.
Yeah, this is just an example I give you. Okay, this is the input format,
Oh,
and
okay, okay. So
the
just like it
code
can
will
be. Okay, okay. I see.
yeah.
Okay.
So yeah, which
Uh,
firstly the question it comes to you should ask you like what data structure and like how you do it. Second part is writing the code. Firstly,
so
decide
yeah.
data structure. Yeah,
So we would use the map, I guess, right?
yeah,
So it'd be
great.
like map bracket int comma int and then frequency.
Exactly. Yeah, yeah, exactly.
Um,
Makes sense. So basically, we'll use like this, and yeah, and then what it will
and
be?
then we would use a for loop, which would just be int,
Yeah.
in this
Mhm.
case, number, right?
Yeah, yeah, exactly. We just
And
iterate on
then
the side, whatever. Yeah,
yeah, and then that
yeah,
would calculate and then it would just be frequency bracket num plus plus to calculate the frequency
yeah,
for each of them,
exactly.
and then we would
Nums of
just
I, yeah, whatever, whatever the index number is,
yeah.
nums of I plus plus. Okay,
Hmm.
great. This is how, yeah, this is how you approach a problem because you know the data structures now. Because you need to understand. Okay, this is the work I need to do. Oh, map is doing this job. That's fine. Let's suppose you want to find whether duplicates present or not in my map. Present. or not in my map, in my vector. So this problem I gave you, let's suppose. So how will you do that? Return me a true, whether the duplicates are present or not. If it is, if it's not present, return me a false.
Hmm.
So, so yeah, let's suppose as the same example, maybe one, two, three, four, five. Yeah, this is like vector, one vector. First example, second example, yeah, like one, two, two, three, four. So yeah, I just want to know whether my vector contains duplicate elements or not. So how would you go about it?
Hmm. And now, sorry, whether duplicate, right?
Yeah, whether duplicates like more than once an element is occurring or not in my vector or not. I just want to know.
Okay, duplicate or not.
Hmm. Like what firstly thing, what data structure we will use, and then we will discuss the algorithm.
Yeah. So the data structure we use would just be unordered set,
Okay. Okay, makes sense. Makes sense. Right.
and
Okay,
then
set.
the algorithm would
Okay.
basically just be
Uh,
we
mm-hmm.
would create an unordered set to store like
Okay.
elements for the vector,
Okay. And
and then we would uh, check if it's first already in the set or not, and then if it
okay.
is, then we would be
Uh,
like, oh, the duplicate exists. If not, then
great. Great. Yeah,
we would
that's
insert it
great.
into that.
Good. Great. Great. Let's try to write the code for that. Good job.
Okay.
Mm, okay. Let's suppose what we are doing is let's just set int comma int s. And you want to know whether the element is. Let's say I give you a vector. Vector int v is equals to let's say one, two, two, five, six. I give you the vector. Let's try to iterate first and last. V dot size, v dot size, and I plus plus. And then what we will do? Firstly, we will check whether this element is present or not. So find v of I is not equals
Yeah.
to L dot n. That means what? It is already present. I'm not inserted here this element, and it's already present. So I will say cow contains duplicates, duplicates, and of L, and then we will just break it off. Okay,
Yep.
and else we'll just insert. Okay, this is how
Yep.
like if it is not present, we will insert it, and if it is present, oh, we find again. We haven't inserted yet because we have inserted for every VA here. But before inserting only it is present means it was previously inserted. Means like here it will be in this block. Here it will be in this block. But here when I reach this two, oh, I already contains my set contains two. So it will contain duplicates. Well, let's try to check it. There's something. Other than that, maybe we don't say something like that. Let me check. Okay. Numerical constant. Wait a second. What happens?
Okay.
So then I vector int v. Okay. Okay. Set int s. Equal to v dot size v of I. Okay. Dot I not equals to what happens? But let's put in what is the numerical constant? What happens? Yeah. I don't know what happens here.
Okay.
They contain duplicates. Okay. Now let's try to do. Let's remove this duplicate. Let's put 7. So yeah, it doesn't give return anything, right? Because we haven't wrote if we didn't find any duplicate, what should we do? So yeah, so yeah, nothing. It doesn't go on this if block, okay?
Yeah.
Because we didn't run any duplicates. So yeah, that's it for today. Mostly we discussed about the STL functions and all. This try to understand, try to write code for find and all, and the simple problems of solving. Yeah, we'll be able to understand it.